You can eat clean, sleep 8 hours, and exercise 3 times a week, and still be losing muscle every single night because your body's overnight repair system is quietly waiting for a signal that never arrives. The mechanism that makes the difference is not what you eat for dinner. It is not your sleep supplement. It is what you put in your body in the first 90 minutes after you open your eyes. And after 55, the window for getting this right is narrower than most doctors will tell you. By the end of this, you will have the overnight forge protocol, 3 specific timed inputs that prime your biology from the moment you wake up to the moment your cells are rebuilding connective tissue at 3 in the morning. But first, we need to talk about the process that is running backward in your body right now and why the mainstream health conversation has consistently looked at the wrong end of the problem. Sarcopenia. That is the villain. Not in a dramatic way. Sarcopenia does not send warning signs. It does not cause pain. It does not show up on a basic blood panel that your doctor reviews at your annual checkup. It is the slow, systematic loss of skeletal muscle mass that begins in your 30s and accelerates after 50, like a car with a slow leak that you do not notice until the tire is completely flat. After the age of 50, the average person loses between 1 and 2% of their muscle mass per year. By 70, that number compounds into a 30 to 40% reduction from peak mass for people who have done nothing specific to stop it. The Framingham Heart Study, one of the longest-running cardiovascular studies in history, found that low muscle mass is one of the strongest independent predictors of all-cause mortality in older adults, independent of body fat percentage, independent of whether someone smokes, independent of most of the variables we are told to worry about. Sarcopenia does not kill you loudly. It just makes everything else more dangerous. Here is the part that most people miss, even people who are paying close attention to their health. Sarcopenia is not simply a consequence of inactivity, it is a consequence of anabolic resistance, a phrase that sounds technical but describes something very concrete and very fixable once you understand it. After 55, your muscle cells require a significantly higher signal to trigger protein synthesis and repair. Think of it like a doorbell that has gotten harder to hear over the years. Before, a light press would ring the bell clearly. Now you have to lean on it hard and hold it. The biological version of leaning on that doorbell involves very specific nutritional inputs delivered at very specific times of day. And the first of those times is the moment you wake up, before you check your phone, before you make coffee, before you have done anything else. In the first 30 to 45 minutes after you open your eyes, your body produces a burst of cortisol that researchers call the cortisol awakening response. This is documented, measurable, and entirely normal. It happens in every healthy person every single morning. Cortisol typically rises by 50 to 100% above overnight baseline during this window. Most people think of cortisol as the stress hormone, the thing wellness blogs are always trying to lower. But the cortisol awakening response exists for a functional reason. It mobilizes stored fuel, sharpens mental alertness, and prepares your cardiovascular and muscular systems for the physical demands of the day ahead. The problem after 55 is that this cortisol spike is running in an environment that is increasingly catabolic, meaning muscle breaking rather than muscle building. Without sufficient amino acids circulating in your bloodstream during this cortisol window, your body borrows raw material from existing muscle tissue to meet its morning energy demands. This is called muscle protein catabolism, and it is happening before you have had your first sip of anything. Your muscles are being quietly disassembled to fuel your morning, and most people are either skipping breakfast entirely, eating carbohydrate-heavy foods that do not provide the amino acid density the body is requesting, or drinking black coffee on an empty stomach, which prolongs the catabolic state by maintaining low insulin without providing any structural building material. The cortisol continues, the muscle continues to be raided, and the person feels completely fine because the body is efficient at managing the deficit, until the accumulated deficit over years becomes visible as frailty, joint instability, or a recovery from illness that takes twice as long as it used to. Before I walk you through the full overnight timeline, I want to address the counter argument because it is the one that kept me from taking any of this seriously for longer than I should have. We have been told broadly that protein timing does not matter very much, that total daily protein intake is what counts, and the body distributes and uses it intelligently regardless of when it arrives. There is some truth to this for younger adults. For older adults, it is incomplete in a way that has real consequences. The Journal of the International Society of Sports Nutrition published a position stand examining this exact question, and the finding for adults over 55 was clear. The distribution of protein across the day matters significantly more for older adults than it does for younger ones, precisely because of anabolic resistance. Muscle cells in older adults are less responsive to smaller protein doses, which means a large protein intake at dinner does not compensate for a protein-deficient morning. The body cannot carry yesterday's amino acids into tomorrow's synthesis window with the same efficiency it could at 35. This is not a minor technical footnote. It changes what should be in your glass when you wake up. So here is the timeline of what actually happens in your body from the moment you consume the right morning drink, and I will define exactly what that means until your cells are completing their overnight repair cycle at 4 in the morning. The drink in question is a specific combination of 5 ingredients, none of which require a prescription, none of which are exotic: hydrolyzed collagen peptides, creatine monohydrate, Montmorency tart cherry concentrate, vitamin C, and magnesium bisglycinate. You mix all 5 into a single glass of water. The biological cascade that follows over the next 16 hours is far more interesting than any single ingredient would suggest in isolation. Call the first stage the cortisol gate. It opens at minute 0, the moment the drink hits your gut. Hydrolyzed collagen peptides are broken down in the digestive tract into their component amino acids and short peptide chains, primarily glycine, proline, and hydroxyproline, and these reach the bloodstream within 30 to 60 minutes. What makes them specifically valuable during the cortisol awakening response is not just the amino acid content, but the signaling function of glycine in particular. Glycine is the most abundant amino acid in collagen, and it is also a direct precursor to glutathione, your body's primary internally produced antioxidant. When glycine levels rise in the morning, you are simultaneously priming connective tissue repair and reducing oxidative stress in cells that are emerging from an overnight fast and a cortisol surge. A study led by Dr. Gregory Shaw at the Australian Institute of Sport and published in the American Journal of Clinical Nutrition found that supplementing with 15 grams of collagen peptides alongside vitamin C before exercise significantly increased collagen synthesis markers in ligaments and tendons compared to a placebo group. The mechanism is specific. Vitamin C is a required cofactor for the enzyme prolyl hydroxylase, which cross-links individual collagen chains into the stable triple helix structures that can actually bear mechanical load. Without adequate vitamin C, the body produces immature pro-collagen chains that cannot be properly assembled. This is why vitamin C belongs in this morning drink, not as a generic antioxidant, but as a specific enzymatic key that determines whether the collagen building blocks being supplied can actually be assembled into functional tissue. Add creatine monohydrate to this picture now, because its role is different from what most people assume. Most people associate creatine with young men trying to increase muscle bulk. The research on creatine in adults over 50 tells a considerably more important story. A meta-analysis published in Medicine and Science in Sports and Exercise by DeVries and Phillips at McMaster University analyzed data from over 140 older adults across multiple randomized controlled trials. The finding: creatine supplementation in older adults produced statistically significant increases in lean muscle mass and upper body functional strength, and these gains were approximately doubled when creatine was combined with even modest resistance training. The mechanism operates on 2 levels. The first is the one most people know. Creatine replenishes phosphocreatine in muscle cells, which is the immediate energy currency for short-duration muscular efforts, the first 10 to 15 seconds of any intense movement. The second mechanism is less well known but arguably more relevant for aging adults. Creatine is osmotically active inside muscle cells. It draws water into the cell through osmosis, increasing cell volume. That increase in cell volume is itself an anabolic signal. The muscle cell interprets volumetric swelling as evidence of increased mechanical demand and initiates protein synthesis cascades in response, even independent of actual exercise. 5 grams of creatine monohydrate in the morning drink is not primarily a gym strategy after 55. It is a cellular hydration and anabolic signaling strategy that begins working within the first hour of consumption and continues amplifying its effects over weeks of consistent use. This brings us to stage 2. Call it the amino acid flood, and it runs from roughly 90 minutes after waking until about 4 hours in. During this window, your bloodstream is carrying elevated glycine, proline, and hydroxyproline from the collagen. Your muscle cells are being rehydrated and osmotically signaled by creatine, and vitamin C is present as a cofactor ready for enzymatic deployment. If you add any resistance-based movement during this window, 10 minutes of bodyweight squats, a set of push-ups against the wall, resistance bands, you activate a cellular pathway called mTOR, which stands for Mechanistic Target of Rapamycin. That name is irrelevant. What matters is that mTOR is the switch that tells muscle cells to shift from maintenance mode into synthesis mode. Think of it as the factory foreman who decides whether the production line runs or idles. Leucine, an essential amino acid found in complete protein sources and in some collagen blends that include gelatin, is the primary molecular trigger for mTOR activation. Here is the catch that the mainstream fitness industry still does not communicate clearly. Younger adults need approximately 1.8 grams of leucine to trigger a maximal mTOR response. Adults over 55 require approximately 3 grams or more of leucine to achieve the same effect. The doorbell needs to be pressed harder. This is why the composition and quantity of your morning protein cannot be casual after a certain age, and why pairing the morning drink with a leucine-rich protein source at breakfast, eggs, Greek yogurt, a complete protein supplement, is not optional if you want the full anabolic cascade to fire. Sarcopenia, the invisible villain introduced at the opening, is operating on exactly this mechanism. It is not just that older adults are eating less protein or exercising less, though both are common. It is that the biological machinery for translating protein and exercise into muscle repair has become less sensitive. The repair signal requires a louder ring. Most people are still pressing the doorbell at the same strength they did at 40 and wondering why the door is not opening. Stage 3 begins around hour 3 to hour 5 after the morning drink, and this is where the tart cherry concentrate stops being passive and starts actively reshaping the inflammatory environment in your body. Call this stage the infiltration window. Montmorency tart cherry contains 2 distinct classes of biologically active compounds, and they work through different mechanisms on the same problem. The first class is melatonin. Tart cherry is one of the few significant whole food sources of dietary melatonin, a molecule your body uses not only to regulate sleep onset, but also as a potent antioxidant that specifically protects mitochondrial membranes from oxidative damage. A study by Watson and colleagues at Northumbria University, published in the European Journal of Nutrition, found that supplementing with tart cherry juice for 7 consecutive days significantly increased urinary melatonin metabolites, increased total sleep duration, and improved sleep efficiency in healthy adults. But here is the mechanism that makes this more interesting than simply adding melatonin to a drink. Tart cherry anthocyanins inhibit the enzyme IDO, which stands for indolamine 2,3-dioxygenase. IDO is an enzyme that normally degrades tryptophan, the amino acid precursor to serotonin and eventually melatonin, before it can complete the conversion pathway. So the anthocyanins in tart cherry are not simply supplying melatonin from outside. They are protecting the body's own internal melatonin production by blocking the enzyme that destroys its raw material. You are closing the drain at the same time you are increasing the flow into the sink. The net result is a measurable increase in nighttime melatonin availability that accumulates over days of consistent tart cherry consumption. The second class of compounds in tart cherry is the anthocyanins themselves, the pigments that give the fruit its deep, characteristic red color. These anthocyanins inhibit cyclooxygenase 1 and cyclooxygenase 2 enzymes, commonly known as COX-1 and COX-2. If those names sound familiar, it is because they are the same enzymes that ibuprofen inhibits, which is the basis of ibuprofen's anti-inflammatory and analgesic effects. A study published in the Scandinavian Journal of Medicine and Science in Sports documented that marathon runners who consume tart cherry juice for 5 days before and 2 days after a race experienced significantly less muscle pain, faster recovery of strength, and lower circulating markers of systemic inflammation than the control group. The relevance for adults over 55 is not athletic performance. It is the condition researchers now call inflammaging, the low-grade persistent background inflammation that accumulates with age and directly interferes with tissue repair during sleep. When your overnight repair systems are active at midnight, chronic inflammaging is the barrier slowing the repair crew's access to damaged tissue. The COX enzyme modulation from tart cherry concentrate begins reducing that barrier from the moment the anthocyanins reach peak plasma concentration, which happens approximately 3 to 5 hours after consumption. Now, here is the mainstream betrayal moment, and this one bothered me for a long time after I understood it. For decades, the standard recommendation for joint and muscle pain in older adults has included non-steroidal anti-inflammatory drugs, ibuprofen, naproxen, aspirin, taken regularly to manage discomfort. Physicians hand these out without significant hesitation, and many older adults take them daily or near daily. What a review published in the Journal of Applied Physiology examined is the downstream effect of this practice on the recovery process specifically. NSAIDs block prostaglandin synthesis by inhibiting COX enzymes. Prostaglandins are inflammatory signaling molecules produced at sites of microscopic tissue damage, the small-scale damage that happens normally when you walk, carry groceries, or climb stairs. Here is what was not being communicated broadly. Those same prostaglandins are part of the signaling cascade that calls satellite cells, your muscle's repair and regeneration cells, to the site of damage. They are also involved in mTOR activation downstream. When you chronically suppress prostaglandin synthesis with regular NSAID use, you are reducing the pain signal, but you are also reducing the repair signal that follows it. A meta-analysis published in Acta Physiologica found that chronic NSAID use in older adults was associated with blunted muscle protein synthesis responses following resistance exercise. The standard recommendation for managing discomfort was inadvertently slowing recovery. Tart cherry modulates this inflammatory environment differently. It reduces the excessive and chronic inflammation component without fully extinguishing the acute repair signaling that healthy tissue maintenance requires. This is not a claim that tart cherry replaces medical pain management. It is a claim that the mechanism of action is meaningfully different, and that difference matters for anyone trying to preserve muscle and connective tissue after 55. Stage 4 is what I call the circadian handoff, and it unfolds across the late afternoon and early evening. Somewhere between 3 and 8 hours before sleep, your body begins a coordinated biological shift. Core body temperature starts its evening decline, a drop of approximately 1 to 2 degrees Fahrenheit that signals the hypothalamus to begin releasing the biological conditions for sleep. The melatonin pathway, primed since morning by the tart cherry compounds, is now responding to declining light exposure. Your hunger-regulating hormones are shifting, and the collagen amino acids that have been circulating in your bloodstream since morning are being progressively directed toward overnight synthesis projects. Think of your body as a construction site. The materials have been delivered throughout the day, and the overnight crew is about to begin its shift. What happens next depends almost entirely on one factor that the conventional health conversation consistently underestimates: the level of insulin in your blood when you fall asleep. Insulin is the key suppressor of nighttime growth hormone release. This relationship is not subtle or marginal. Growth hormone is released by the pituitary gland in pulses during slow-wave sleep, primarily during the first deep sleep cycle, which begins approximately 45 to 90 minutes after you fall asleep. Insulin directly suppresses this pituitary release. Research published in the Journal of Clinical Endocrinology and Metabolism established that growth hormone secretion declines by approximately 14% per decade after young adulthood. By the age of 60, many people are producing 60 to 70% less growth hormone during sleep than they produced at 30. This is the biological reality of aging. But the additional suppression from elevated bedtime insulin is not an inevitability of aging. It is a consequence of eating late, eating high carbohydrate foods in the evening, or simply not allowing enough time between dinner and sleep for insulin to clear. Here is a number that took me a long time to accept the implications of. During extended fasting states, growth hormone levels can increase by up to 1,300% compared to fed state baselines, according to research published in the Journal of Clinical Endocrinology and Metabolism. The mechanism is straightforward. When insulin drops significantly, the pituitary gland is released from suppression and allows its GH pulses to reach something approaching what a 25-year-old body produces overnight. I am not recommending extended fasting as a universal strategy. I want to be explicit about that because individual health circumstances, medications, and metabolic status vary enormously, and anyone with existing conditions needs supervision before changing feeding windows. But the 1,300% figure illustrates the magnitude of the hormonal lever that insulin represents. The difference between an insulin-suppressed overnight repair window and a low insulin overnight repair window is not a nuance. It is the difference between the factory running on one engine and running at full capacity. The magnesium bisglycinate in the morning drink now becomes the most underappreciated element of the protocol. Here is why timing it in the morning rather than just before bed matters in a way most magnesium recommendations miss. Magnesium is a cofactor in over 300 enzymatic reactions in the human body. Among those reactions, messenger RNA translation, which is part of protein synthesis, ATP production in mitochondria, and the activation of GABA receptors in the central nervous system. GABA is the primary inhibitory neurotransmitter, the chemical signal that quiets neural activity and allows the brain to transition from wakefulness to sleep states. When magnesium is insufficient, GABA receptor sensitivity is reduced. The quiet down signal becomes weaker. The consequence is lighter sleep, more nighttime waking, and less time spent in slow-wave sleep, the deep phase where growth hormone pulses are concentrated. Approximately 48% of Americans consume less than the estimated average requirement for magnesium, according to data from the National Health and Nutrition Examination Survey. This is not a marginal deficiency in a small population. It is a systemic shortfall affecting roughly half of all adults, and its impact on sleep architecture is clinically documented. The reason the morning timing matters is that magnesium's role in protein synthesis and cellular energy production during the day is separate from and additive to its role in sleep quality at night. When you take magnesium bisglycinate in the morning, you are addressing the daytime enzymatic functions, protein synthesis, mitochondrial efficiency, at the time they need support. By evening, magnesium tissue levels are reaching their peak, which is precisely when GABA receptor modulation becomes relevant for sleep onset and depth. You are getting the benefit of magnesium across the full daily arc of repair, not just the final hours of it. At this point in the story, I want to pause because this is exactly where I fell short for longer than I should have. I had read about all of this. I had bookmarked the studies. I had a folder on my laptop with papers on magnesium and sleep, on collagen timing, on anabolic resistance. And for about a year, I did almost nothing systematic with any of it, because reading research and building a daily structure out of it are genuinely different skills. My husband, Mark, had been quietly doing the work of turning the research into something usable, partly for himself, partly because he watched me bookmark things and never act on them, which I think quietly amused him. He built a 30-day daily companion called the Noon Reset Protocol. It is 2 pages per day, one page that explains the science behind what is happening in your body on that specific day of the protocol, and 1 page of a tracker so you are not improvising. He structured it into 4 phases: adaptation, activation, optimization, and acceleration. For what we are discussing in this video specifically, the connective tissue repair, the sleep architecture, the overnight growth hormone window, the adaptation phase walks you through exactly how to introduce the morning drink combination and what to expect in the first 10 to 14 days while your body adjusts. It also includes 25 breakfast meal ideas with exact protein counts per serving, because the morning drink is the ignition, but the first full meal determines the amino acid supply available for the full synthesis window. The guide is available through the link in the description for less than you would spend on a single restaurant meal. But let me finish the overnight timeline because the last two stages are where the biology gets genuinely surprising. Stage 5 opens approximately 45 to 90 minutes after you fall asleep. Call it the first repair wave. Slow wave sleep, what researchers classify as N3 sleep, is the stage in which your brain waves slow to their most synchronized, low-frequency rhythm, and your body enters its peak anabolic state. The pituitary gland releases its largest growth hormone pulse of the night during this stage. The amino acids that have been circulating since the morning drink, glycine and proline from the collagen phosphocreatine saturating the muscle cells, leucine from the day's protein intake, are now being assembled into new tissue. Your muscles are being repaired from the micro damage of daily movement. Tendons are being rewoven with new collagen fibers. Bone matrix is being updated. Think of this stage as a night shift factory that has been operational all day but has been waiting for the raw material delivery to be complete before running the final assembly. The morning drink did not build this factory. It ensured the delivery truck arrived on time with the right materials. One finding that gets almost no popular coverage: slow wave sleep decreases dramatically with age. Adults in their 20s spend approximately 20 to 25% of total sleep time in slow wave sleep. By 60, that figure drops to approximately 5 to 8% in many individuals. This is not because older adults sleep less. It is because the architecture of sleep changes. The ratio of light sleep to deep sleep shifts, and the deep sleep becomes shorter and shallower. This is one of the reasons the growth hormone pulse diminishes so significantly with age. It is not only that the pituitary produces less growth hormone, it is that the trigger for the pituitary to release it, slow wave sleep, is occurring less frequently. Anything that improves sleep architecture in older adults, including magnesium, including Tart cherry melatonin support, including the body temperature drop facilitated by a cooler sleep environment, is directly increasing the time spent in the stage where GH is released and tissue repair is occurring. Stage 6 begins in the hours that most people are deepest into unconsciousness, somewhere between 1 and 4 in the morning. Call it the cleaning crew. In 2016, Japanese cell biologist Yoshinori Osumi received the Nobel Prize in Physiology or Medicine for his work on autophagy, the process by which cells systematically identify damaged proteins, dysfunctional organelles, and accumulated cellular debris, dismantle them, and recycle the component molecules. Autophagy is not passive housekeeping. It is a regulated, highly selective process that is one of the primary biological defenses against the cellular dysfunction that underlies cancer initiation, neurodegeneration, metabolic disease, and the general deterioration associated with accelerated aging. Think of it as the building manager who walks the factory floor in the middle of the night with a clipboard, pulling broken equipment off the production line, cataloging what can be repaired, sending what cannot be repaired to the recycling facility, and logging everything for the morning shift. Autophagy is activated by low nutrient, low insulin conditions. The overnight fast, the hours between your last meal and your first meal the following morning, is your body's primary autophagy window. The depth and efficiency of that window depend on how early you stopped eating, how well you sleep, and how low your insulin levels are during the overnight hours. If you eat a large meal at 9 in the evening and fall asleep at 11, your insulin is still meaningfully elevated past midnight, and autophagy is suppressed during the very hours it should be running at maximum efficiency. The cleaning crew arrives at the factory and finds the manager's office locked. The debris accumulates, and over years, accumulated cellular debris, particularly in neurons and in metabolically active tissues, contributes to the dysfunction that we observe as accelerated biological aging. The magnesium from the morning drink has a specific role in this stage that goes beyond sleep quality. Magnesium is required for the activation of ATG proteins, autophagy-related genes that initiate the autophagic process within individual cells. Research published in the journal Autophagy found that magnesium status directly modulates the efficiency of a specific subset called mitophagy, the targeted identification and removal of damaged mitochondria. Your mitochondria are the organelles that convert food energy into the ATP your cells run on. When mitochondria are damaged and not cleared by mitophagy, they begin producing reactive oxygen species, molecules that damage surrounding cellular structures through oxidation. Keeping mitophagy efficient keeps your cellular power plants clean, which keeps the energy output of every cell in your body higher than it would otherwise be. The magnesium you consumed with breakfast is at 2 in the morning, maintaining the quality of your cellular energy infrastructure in a way that no single supplement or behavior could replicate alone. The final stage, what I call the collagen factory, runs from roughly 4 in the morning through to waking. During the final REM cycles of the night, when core body temperature is at its lowest and the brain is paradoxically active during dreaming, fibroblasts, the cells responsible for synthesizing collagen, are in their most active production state. Collagen is the most abundant protein in the human body, constituting approximately 30% of total protein mass. It forms the structural scaffolding of skin, tendons, ligaments, cartilage, the organic matrix of bone, arterial walls, and the cornea of your eyes. After the age of 40, collagen production declines by approximately 1% per year, a rate that accelerates significantly after menopause in women due to the loss of estrogen's protective effect on collagen synthesis. The structural consequences of this decline are more than cosmetic. Tendons progressively lose water content and become stiffer and more brittle. The organized architecture of collagen fibers and ligaments becomes less regular, reducing their tensile strength and elasticity. This is a primary reason why musculoskeletal injuries become more frequent and slower to heal after 50, not simply because of muscle weakness, but because the connective tissue matrix surrounding those muscles has degraded in ways invisible to standard clinical assessment. The vitamin C you consumed in the morning is now serving as the molecular key in this stage. Prolyl hydroxylase, the enzyme responsible for cross-linking individual collagen chains into stable triple helix structures, is dependent on vitamin C as a required cofactor. Without adequate vitamin C, the body produces procollagen, structurally immature collagen chains that cannot form proper crosslinks and cannot bear mechanical load. This is the molecular basis of scurvy in its early subclinical form. Joint pain and tissue fragility are the first manifestations, long before the more dramatic symptoms of advanced deficiency appear. Most adults over 55 are not vitamin C deficient in the clinical diagnostic sense, but many are running at levels sufficient to prevent deficiency disease and insufficient to support collagen cross-linking at peak rates during the hours when fibroblast activity is highest. The difference between 60 milligrams of vitamin C per day, the standard recommended daily value, and 300 to 500 milligrams of vitamin C per day is not just a number. It is the difference between the collagen factory running at partial capacity and running a full overnight shift. And none of this happens with any efficiency if the sleep that contains these final repair hours is fragmented, light, or cut short by an alarm that interrupts the final REM cycle. This is the chain that runs from morning to midnight, and it is the chain the overnight forge protocol is designed to keep intact. Here is how the protocol works in 3 specific, non-negotiable components. The first component is the morning load, consumed within 30 minutes of waking. Combine 10 to 15 grams of hydrolyzed collagen peptides, the hydrolyzed form specifically, as the molecular weight is reduced to a size that significantly increases gut absorption, with 5 grams of creatine monohydrate, 30 milliliters of Montmorency Tart cherry concentrate, 200 to 500 milligrams of vitamin C, and 200 milligrams of magnesium bisglycinate. Mix into 8 to 10 ounces of water and consume before or alongside a leucine-rich breakfast. The 30-minute window after waking is not arbitrary. It is calibrated to intersect with the peak of the cortisol awakening response to populate the amino acid pool and activate cellular signaling before the catabolic window deepens. Follow this with a breakfast that contains at least 30 grams of complete protein to reach the leucine threshold for mTOR activation in older adults. The second component is the activation signal, performed within 2 hours of the morning drink, before insulin levels from breakfast have risen significantly. This is 10 to 20 minutes of resistance-based movement, not cardio, not a walk, not stretching. Resistance, body weight squats, wall push-ups, resistance band rows, a brief dumbbell circuit. The purpose is to mechanically activate the mTOR pathway that the morning amino acids have primed but cannot fully trigger on their own. Movement acts as a second molecular key that amino acid availability cannot replace. Without this activation step, the collagen and creatine circulate and are partially utilized, but the full anabolic cascade, the factory foreman calling in the full production shift, does not engage. The movement does not need to be intense. It needs to create tension in the major muscle groups and signal to those cells that mechanical demand is present. The third component is the repair lock. This is defined by what you stop doing in the 3 hours before your target sleep time. Stop eating at least 3 hours before sleep. Not because of calorie concerns, not because of digestion, but because of insulin clearance. For most metabolically healthy adults, insulin returns to near baseline within 2 to 3 hours of the last meal, though this window is considerably longer in individuals with metabolic dysfunction or type 2 diabetes, which is another reason that individual medical context matters. Allowing this clearance removes the primary suppressor of the overnight growth hormone pulse and opens the autophagy window at the biologically appropriate time. Additionally, lower your sleep environment to between 65 and 68 degrees Fahrenheit. Core body temperature decline is one of the primary circadian signals the hypothalamus uses to initiate slow-wave sleep. A room that is too warm delays this decline, compresses the first deep sleep cycle, and reduces the window available for the growth hormone pulse. This is not a preference. The temperature difference between a room at 72 degrees and a room at 66 degrees is measurable in sleep architecture outcomes documented in sleep laboratory research. The single most common mistake that invalidates the overnight forage protocol is applying the first two components correctly and then undermining both of them with a late dinner that keeps insulin elevated past midnight. The morning amino acid delivery and the afternoon anti-inflammatory work and the creatine saturation of muscle cells, all of it flows toward the overnight window. The overnight window cannot be held open by willpower or intention. It operates on the schedule set by your circadian rhythm and your hormonal environment. Break the insulin clearance component, and you suppress the growth hormone pulse, blunt autophagy, and reduce slow-wave sleep quality simultaneously. You have done the morning work and locked the factory doors before the night shift can begin. If you are going to start the overnight forage protocol this week, comment the word foraging below so I can see who is actually committing to this. The people who comment are consistently the ones who follow through, and I pay attention to those names. If this channel is new to you, subscribe, because this is what I put out consistently. Mechanisms, not motivation. The studies that most people do not read, translated into what they actually mean for a body over 55.